Okay, we are going to talk about the chain rule. As you would see, this is 3.6. The chain rule is stated as follows. If f of u is differentiable at the point u is equal to g of x and g is differentiable at x, then the composite function f compose g at x is equal to, which is f gx, is differentiable at x, and the derivative is going to be equal to derivative of f at g and times the derivative of g. We can use the Leibniz's notation as well. This is what the Leibniz's notation, Leibniz found out that notation, and it's very useful. So we can use that, okay. And here dy dx is equal to dy du, du dx. Okay, so dy du in this case, you can consider that it's going to be evaluated at g. Okay. Okay, we are not going to do the proof here, but we are going to just do applications, which we already did once. There's an outside-inside rule I mentioned during the recitation as well. Let's go over the outside-inside rule. Let's look at this example. When you look at actually, before we get to it, the g here. Do you see that g is the inside function, f is the outside function? When you compose, like in here, y is equal to f compose g is the inside function, f is the outside function. Once you know that, then the derivative of y with respect to x is going to be equal to derivative of the outside function evaluated at g times the derivative of the inside function. You can see it like this. Let me make it bigger for you. Okay, just a little bit more. Alright, so let's do an application. Here differentiate sine x squared plus x with respect to x. Here we have the inside function x squared plus x, outside function is sine. If you want to take the derivative of this, which is d over dx, the derivative of the original function, we are going to take the derivative of the outside function. Outside function is sine, derivative is cosine, and we have to evaluate this at the inside function times the derivative of the inside function, which is 2x plus 1, right? Okay, and there's another part which I mentioned in the recitation as well, repeated use of the chain rule. Sometimes we may have more than two functions composed, and if you want to do the chain rule, if you want to take the derivative, you have to apply the chain rule repeatedly. For example, here you have the g, and we have tangent outside function, and we have 5 minus sine t 2t as the inside function, but we also have 2t as an inside function of sine. So function inside another and inside another. So we have three functions that are composed. So we have to apply the chain rule twice. Let's apply it now for the first time. G prime is equal to derivative of the tangent 5 minus sine 2t. The derivative of the outside function is secant squared, and keep the inside function as it is, times it with the derivative of the inside function. Now this function has, of course, sine 2t in it, so it's a composition of sine and 2t. So we are going to apply a chain rule here again. The derivative of 5 is 0, and here the derivative of the constant 5 is again 0, as I told you, and the derivative of sine 2t, what is the outside function, is sine here. The derivative of sine is cosine. We evaluate at 2t, and then multiply this with the derivative of the inside function, which is the 2t, and here, as you will see, secant squared 5 minus sine 2t times, this is 0, so we ignore it, minus cosine 2t times the derivative of the 2t, which is 2. Okay, and then at the end we just write our answer in a simplified format. So these things you will see as well, and we did an example in the recitation as well. And let's see, there's a power chain rule, which in this case n is a real number, f is a power function, as you would see here, f of u to the n. The power rule tells us that the derivative is going to be take the power to the front and reduce the power by 1, right? This is what we learned about the power rule. But this is chain rule combined with the power rule, okay? So in this case, u is going to be a function of another, it's going to be composed functions, okay? So let's see the next page. Let's get this example. Let's use the power chain rule here and find the derivative of this expression. As you will see, we have the base and we have the power 7. the base is 5x cubed minus x to the 4 and the power is 7. This is like composition of two functions. The inside function is 5x cubed minus x to the 4. Outside function is x to the 7. Alright, so the power chain rule says take the power to the front and then decrease the power by 6 and keep the inside function and take the derivative of the inside function. The derivative of the inside function, as you would see, this is going to be 15x squared minus 4x cubed, and you get the answer. Here you can consider u as the inside function. You can name it as 5x cubed minus x to the 4 if you want to use the Leibniz's rule. And here's another example B. We want to take the derivative of 1 over 3x minus 2. First, you would need to write this as in powers, as I told you in the recitation as well. 3x minus 2 to the negative power. You take the power to the front, decrease the power by 1, multiply this with the derivative of the base or derivative of the inside function. And derivative of the inside function is 3, okay? And we rewrite the answer as a positive power, which means the denominator has a positive power instead of having it written as negative power. It is the best if you do it whenever you get to it. In example 6, we have an extraordinary situation. Example 6 is a nice example because for the first time we are going to learn how to take the derivative of an absolute value of x. For this, let's remember what absolute value of x is. Absolute value of x is square root of x squared, right? So in other words, taking the derivative of absolute value of x is the same as taking the derivative of square root of x squared. So how would you do that? You can write this as, okay, you can take the inside function as x squared. You can apply the chain rule. We have the power. Take the power to the front. Power is 1 over 2. Take the power to the front. Decrease the power by 1. Negative 1 over 2. Okay, so we were talking about this absolute value, the derivative of absolute value. And I said that the absolute value of x is equal to square root of x squared. And I said that the derivative of square root of x squared, you can treat this as power rule. Take the power to the front and take the derivative of the outside function, which is 1 over square root of whatever inside, times the derivative of the inside function, here x squared you have. Okay, therefore we have 1 over 2 square root of x squared, but we know square root of x squared is absolute value of x, and the derivative of x squared is just 2x. The answer is, 2's are going to cancel. The answer is x over absolute value of x. X is never 0. So this tells us that actually to the right and to the left of x, the derivative will take different values. Therefore, at x is equal to 0, it doesn't exist, right? If you see this, whenever x is bigger than 1, the derivative is 1. Whenever x bigger than 0, I'm sorry, whenever x is less than 0, it's negative 1. They never agree, so it's 0. Absolute value is not differentiable. We have another question here, which is show that the slope of every line tangent to the curve is positive. So what we are going to do, we are going to just calculate the slope of this of the tangent line to the curve at a point x. What you need to do, you need to take the derivative, because slope is the same as taking the derivative at a particular point x. So here we are going to write this as a power rule, power form. So this is going to be y is equal to 1 minus 2x to the negative 3, and then you're going to take the derivative of this, take the power to the front, negative 3, decrease the power by 1, you get negative 4 on top, and the derivative of the inside function, right, is negative 2. So we applied the chain rule, and we apply the power chain rule because we have the power here, so we had to apply the power chain rule. So power rule plus chain rule is the power chain rule. Okay, so that's an example. We did such examples in our class as well, in our recitation as well. So I'm going to skip this example, we don't need that. We did some problems in class, and I'm going to solve a little bit more of that here right now. Okay, we are going to solve the problem 60 in our book. You can see that here the g of x is given, and we are going to, let's see, we are going to, let me see, okay. we are going to find the second derivative of this function. What is g? I'm going to write the g here, g of x. G of x is equal to 1 minus square root of x to the negative 1. Okay, so here we are going to find the first derivative first. Okay, the first derivative, which is g prime at x, is going to be equal to, we are going to apply the power chain rule. So I'm going to write that, apply power chain rule. Okay, so what does the power chain rule says? Take the derivative of the power, take the derivative of the outside function and decrease the power by 1, and take the derivative of the inside function. Derivative of the inside function is 1 minus square root of x. Okay, so this is going to be equal to negative 1 minus square root of x to the second. Here we are going to continue writing it down. 1 minus square root of x, we raised it to the positive power 2. The derivative of 1 is 0, and the derivative of square root of x is, you can consider this as x to the 1 over 2. We apply the power rule, 1 over 2, 1 over square root of x, right? So that's what it is. And now what's the answer? Is that we have minus here, minus, it becomes positive, and we have 1 over 2 square root of x and 1 minus square root of x to the second power. Okay, we have that. Alright, so that's the first derivative, but they're asking us to find the second derivative here, so we have to take the second derivative now. Okay, so the second derivative, so I'm gonna write that this is g double prime at x, so this is the derivative of this expression, right? So the derivative of, I'm going to write this in negative powers. Okay, so 1 over 2 x to the negative 1 over 2, and here 1 minus square root of x to the negative 2. Okay, I want to use the product rule here. Okay, I just chose it to be. And here we have 1 over 2. This is the product of the two, so I'm going to keep the first one as it is, and take the derivative of the second, Okay, we just write it down. Here we are going to write the derivative of the second one, which is 1 minus square root of x, negative 2. We are doing the product rule, and take the derivative of the first. Since this is a constant, I just take it out. Times the second one. Okay. Okay, next we are going to write down the derivatives. Okay, let's use a different color here. Okay, what's the derivative of this? Okay, this is the power rule. We said that take the power to the front. Okay, decrease the power by 1, and take the derivative of the inside, which is, okay, there's negative here, this is 0, the derivative is 0, the derivative of this is negative 1 over 2, 1 over square root of x. Okay, negative 1 over 2 square root of x. Alright, this is it. And what's the derivative of this? Let's use a different color. Let's use the blue color here. Okay, for this one, we have negative 1 over 2, decrease the power by 1, you get negative 3 over 2. So we want to write down our answer. Let's see whether we can write this in this answer. So g double prime at x is going to be equal to alright, so I'm going to write it 1 over 2, okay, 1 over square root of x, alright, and this one is positive 2 because I have negative. So we have plus 2 here, negative 2 times negative 1, and then we have, okay, we continue here, and we have 2 here, so divided by 2, and let's see, we have 1 over square root of x again here, okay, coming from here, and this comes from here, and we have this, and the positive power is 1 minus square root of x to the third power, and then we have these terms plus negative 1 over 2 here, 1 over 2 here, it makes negative 1 over 4, so I'm going to erase the plus here, and I'm going to make it negative, negative 1 over 4, okay, 1 over square root of x cubed here times 1 over, let's move this towards right a little bit if we can. Let's see if I can do that. Yeah. And then here 1 minus square root of x to the second power. Okay, so I have that. Now if I want to simplify, I can. Let's try to simplify it. I am going to open up some room here. Okay, so I have, let's simplify some of these things here. Too much. Okay. Here we are going to cancel the terms. So I have this. I have lots of 2's here, so this cancels with this, and this combines with this. So what do I have here is 1 over 2, 1 over x, and this term 1 over square root of 1 minus square root of x cubed. Okay, and then minus, and I want to simplify this part. Okay, I want to get towards right a little. Okay, any cancellations here? Not necessarily. So I have here, let's write it down. I have here negative 1 over 4, 1 over x, square root of x, because 1 over square root of x cubed is equal to this, and 1 over 1 minus square root of x to the second power. Okay, and then so we have x here, 1 over square root of x squared. Maybe I can factor that out if I want to, or I can leave it like this, but I can do a little bit more. 1 over 2 times x times 1 over 1 minus square root of x to the second, actually cube, let's say. Take this out. Okay, when I take this out, I have 1 here, and I have negative 1 over square root of x times 1 minus square root of x, and that's it. Okay, because if I multiply this with this, I should get the squared back. That's the only way, and x times x is like that. And I think, let's see, I forgot to write 1 over 2. Let's see, 1 over 2, there should be a 2 here. Okay, otherwise it doesn't make 4. Okay, this is the final answer here. Okay, similarly we have other examples here. let's work on this. Let's place some room here. Alright, let's move up, and this is a question. Okay, leave some blank here. Alright, so here h is equal to this, so I'm gonna first find h prime. H prime is equal to, this is a little bit dark, so let's make it less dark. H prime is equal to, what's the derivative of 10? This is secant squared, so it is 9 times secant squared, the inside function, this was the derivative of the outside function 10, times the derivative of the inside is 1/3. So the answer is 3 times secant squared x over 3. Okay, this is 1, and I'm going to take the derivative one more time. And what's the second derivative here? The second derivative of h is going to be, okay, it's the derivative of, sorry about that, it's the derivative of this expression, so I'm going to write it down. So this is 3 secant squared x over 3. Okay, close it. So let's take the derivative of this. This is a constant. The derivative of secant squared is, okay, we have power rule here. Okay, this is the power, so let's circle this. This is a power. Okay, so we are going to use power chain rule, and according to that we take the 2 out. Secant, decrease the power by 1, x over 3, so we are going to do repeated chain rule as well, times the derivative of the inside function, the derivative of secant x over 3. Okay, so you see that we have a repeated chain rule. So this is 6, this is secant x over 3, and this is the derivative of secant x is secant tangent secant x over 3, tangent x over 3, I'm sorry, tangent x over 3, and the derivative of the inside function, derivative of the x over 3. Inside function is x over 3. Okay, and then we go one more step here, down here. Okay, almost done. Okay, from here actually we are going to get 1 over 3. So 1 over 3 times 6, 6 over 3 is 2. Okay, I have secant x over 3. Let me circle that and tell you. So this thing is 1 over 3. So I used it up here. Okay, and let's continue. Secant x over 3. I have 2 of those. This is going to give me secant squared x over 3, and then tan x over 3, and this is going to give me 2, and I'm done. So this cancels, and this gives me 2. That's the final answer. Okay, let's do one more. Actually, I have a couple more here. Let's see. Let's see here. Yeah. Maybe. Let's do the example 3 instead. Here we are going to solve example 3 here, and in example 3, as you will see, it says find the value of f composed g, derivative of f composed g at x at the given value of x. When we are given f of u is given in terms of u plus 1 over cosine squared u is given as g of x, which is pi times x, and x is given to be 1 over 4. So we are going to find the f composed g, the derivative of that. So this is the chain rule that we know of. Okay, so solution is as follows. Okay, solution. So we are given f of u is equal to u plus 1 over cosine squared u, yeah, and then g is the same as u. Actually, u is equal to g of x, another name to it. is just pi times x, alright, and x is equal to 1 over 4. So they want us to find the derivative at the given value. Actually x is equal to 1 over 4. Okay, alright, so let's move down. So we are going to use the chain rule. As I said, the derivative of f composed g at x is the same as, okay, derivative of f evaluated at g and the derivative of g, right? This is what the chain rule say. So f prime actually at u is g, times, okay, u prime at x. That's the same thing, yeah? So we are going to find the derivative of f at u. So let's take the derivative df du. Df du is 1 plus, how would you take the derivative? Let's do it slowly so that you can follow. So I'm going to erase this. You should see what we are taking here. So here d over du of u plus cosine u to the negative 2. So I just write it in negative powers because it's easier. Okay, so the derivative of u is 1. The derivative of this is negative 2, power chain rule. Okay, negative 2 cosine u, decrease the power by 1, negative 3, and then take the derivative of the inside function, negative sine x. Okay, the derivative of cosine is negative sine x. So we got that, right? Sine of u, I'm sorry, I made a mistake here. Okay, it should be u, isn't it? Okay, this should be u because everything is in terms of u here. U. Okay, so then let's go down here. And then I am going to plug in the x values for u. So this is going to be 1 minus 2 cosine, what is the u? U is pi times x. So I'm going to write pi x because I have to convert everything to x. Raise it to the power negative 3 here, and then negative sine pi x. Okay, and then so the derivative of f composed g at x is equal to derivative of f at u times du dx, yeah? In terms of the Leibniz's formula. I found this part. This part is it. Okay, it's here. This is it. And then what is including this, of course? And what is du dx? Du dx is just pi, right? So the answer is then pi, right? And then 1 minus 2, okay, there's 2 minuses, plus sine pi x over cosine cubed pi x, and close it. Okay. So this one is, let's write it again. Okay, this one is pi, and this one is here, all of this. Okay, so we got that.